All right, let's continue with the available reports that Excel Solver will generate, and those are the answers, the sensitivity, and the limits report. And the easiest is really the answer report. So what it tells you is, and let me go back to the original setting. So you see we have, initially we had the unit profits of 10 and 10, and we had the solution of 8 and 2. So let's reset everything to 0, 0. Let's quickly run Solver. So that's still all the same, nothing has changed. And so now we are back to 8 and 2, and then we check those answer, sensitivity, and limits report, but I already pulled them up. So when we look at the limits report, at the answer report, all it tells us is that the original value, well, in this case it was 100, so let's do it again. Let's repopulate them. Let me delete quickly the answer report again. And the sensitivity report, delete. And the limits report. Okay, so we start with 0 and 0. And so now we click on Solver. Okay, solve. Let's get all reports. So now let's take a look at the answer report. And so you see here it says original value 100, but our original value was actually 0, and the final value was 100. Then the original values were 0 and 0, and the final values are 8 and 2. And then we have information on the constraints, and that is the same as on the slide. So the cloth total usage, we have 18, and it's a binding constraint, meaning there is no slack. But we have some slack for the glue, namely 4, and we have some plastic. We don't have any slack in plastic, so that's a binding constraint too. Okay, so the answer report, provides useful information, but basically what are the final values, how many units shall we use of each, and are the constraints binding or not. So we can see that here in our graph that the optimum solution is here at 8 and 2. And we can indeed see that the cloth constraint and the plastic constraint, they are binding, but there is some slack for the glue constraint. And I just see that maybe I should make the plastic constraint also, give it a little bit stronger weight. So that was the answer report. So the most important report that Excel can generate is the sensitivity report. So let's see what we have here. So I open up the sensitivity report, and again you see the optimum quantities, Bernoulli's 8 and 2. And then we have something here, reduced cost. I put that on hold for a while. Then it says objective coefficient 10 and 10. And then it says allowable increase, Bernoulli's is 10, or allowable decrease is 5. So what does that mean? The allowable increase means that unless the objective coefficient of 10 does not increase by more than 10, you do not have to consider another optimal combination of producing Bernoulli's and Nightingales. In other words, it will stay at 8 and 2. So let's see what that means. So it says allowable increase Bernoulli is 10. Okay, so that means, let's say the unit profit were 19. Okay, things change, but what matters is this one here, the optimum quantities. So let's see if we run solver. Okay, it's all still the same. Solve. You see the optimum solution is still 8 and 2. Yeah, we make a higher profit, but what matters is for the allowable increase or decrease that we don't have to consider a new solution. Okay, let's cancel. But let's say, and you see that the ISO profit line is now almost close to the plastic constraint. And what would happen if we have more than 20, let's say 21? I think it was actually Bernoulli. So let's go back to 10. And here we do 19. Nothing should happen. So solver, solve, 8 and 2. Cancel, but now let's make it 21. Go to solver, solve. Okay, you see now the new solution is to produce only 9 and 2. Let's do it again. Solver, solve, and then keep solver solution. Okay. So now it is 9 and 0. So now we would only produce Bernoullis. So the sensitivity report tells you that the allowable increase is the range by which the unit profit, in this case the objective parameter or the objective coefficient, can change before you need to consider a new optimum allocation of producing Bernoullis and Nightingales. And the same for allowable decrease, and that would be the same idea. So next, let's take a look at the shadow price. So it says that the cloth has a shadow price of 3.33. Okay, shadow price is what we, in economics, we call the shadow price sometimes opportunity cost. So let's see what that means, 3.33. So, but let's first go back to our original setting. And let's restore again the optimum solution of 8 and 2. So solver. Okay, so now we should see 8 and 2. Okay. So we are back to where we started. So let's say, what is the opportunity cost if I reduce 1 unit of cloth? So in the sensitivity report it says we use 18 units, and from the limits report we also know that from the answer report we also know that cloth is a binding constraint. So the question now is, what if we had 1 unit less? So if instead of 18 we had 17, and please look at the total profit. So now let's solve it. And you see that the total profit goes down by 3.3333. But at the same time, if we had, for example, let's do again 18, which we started with. Okay, so that's where we started. What if we had 19? So if we had 19 units of cloth, and we go, and we solve it, keep solver. So now we have 3.33 units more total profit. That's the shadow price. But we are also told that the allowable increase is 6. Okay, let's see what happens at 6. So that means from 8 to plus 6, that's 24. So now you see that the cloth constraint, which is the orange one, shifts to the 12. That means if you do more than 12, if you do more than 24, let's say 25, now the cloth constraint is no longer anymore the one that is the strongest constraint. It will be the constraint that bites the most is now the plastic constraint. So that means we can only expand cloth by 6, and then we will increase 6 times the profit by 3.33, so total profit should go up to 120. So let's consider this one and solve it. Okay, and you see that indeed the profit is now 120. But we also have now a new optimum solution, because now we would produce only Bernoullis and no Nightingales. Okay, so this is what the shadow price tells you. And we can do the same thing for glue or plastic. I still want to talk quickly about reduced cost. So let's go back again to where we started, which is we had 18, and so we should see 8 and 2. Let's go to solver, and now we are back to 8 and 2. And the sensitivity report shows you under reduced cost 0, 0. So let's consider the example, and let's create a new sensitivity report. Let's say the Nightingales become so popular that the price goes up to 25. Let's see what happens. Okay, so let's say the price goes up to 25. What is now the optimum combination? Let's solve it. Okay, so now we would produce 4 and 4. Let's see what we get if we look at the sensitivity report for this price. So let's click again quickly on solve, and I want to see now the sensitivity report. So now I have a second sensitivity report for the situation where the price, the unit profit for a Nightingale is 25. The reduced cost, it still says 0, so what does it mean? Okay, let's delete that sensitivity report. And let's see what happens if the Nightingale price goes up to, let's say, 50. Let's solve it. Solve. Okay. Okay, so now we would produce only Nightingales, namely 5. Okay, let's take a look at the corresponding sensitivity report. So solve, and let's take a look at the sensitivity report. Okay. And now, so now we have a new situation. Now it says reduced cost is negative 2.5. And it says final value 0. So what that means is the reduced cost means if you could reduce cost by 2.5 units, or you can increase the unit, so we produce 0 Bernoullis, right? So, and now we see next to the Bernoullis of 0, the reduced cost of 2.5. What that means is if the unit profit of a Bernoulli went up by more than 2.5, which is equivalent to saying that the unit cost goes down by 2.5, holding everything else constant, which will increase your unit profit by 2.5. Then you would have to consider, or then you would have to introduce actually Bernoulli's. So in other words, the reduced cost tells you if you don't produce anything of a decision variable, so in this case Bernoulli's, then by how much would the unit profit have to increase, which is equivalent to saying by how much would the unit cost have to decrease, so that you have to introduce that good or that product into the market and start producing it instead of producing zero. So let's double check. So let's say if the unit profit were 13, which is slightly above 2.5, and we solve it, that zero for Bernoulli's should disappear. So let's check. Solve. Okay. And now we are back to 4 and 4. Okay. But let's reset everything again to where we started, which was 10 and 10. And let's solve it. And we are back to 8 and 2. Okay. Actually, here, let me produce again the reports as well. And then I already have the report, so let's just delete sensitivity report 2. Okay. So now we have the sensitivity reports, and now we know reduced cost, what that means. Allowable increase and decrease and shadow price. That's all clear. Okay, so now let's move to the limits report. And the limits report basically tells you what happens if you lose the production of an entire product line. So our optimum is that we produce 8 Bernoulli's and 2 Nightingales. And our profit is 100. If we lost all 8 Bernoulli's, our objective would drop to 2. But if we produce the 8, our objective, which is the profit, goes up to 100. So that means the way you can look at it is if you go from one limit in production to the other, basically 0 to 8 in Bernoulli's, you know that your profit will change from 20 to 100. So the Bernoulli's, they are quite important. You know, if something goes bad with the Bernoulli's, you know, you may lose a lot. For the Nightingales, not that much happens. I mean, if you produce 2, but if you lose the 2, your profit will drop from 100 to 80. So why is this useful information? So let's say you produce the Bernoulli's in 2 different locations. Let's say 2 different countries, but one country is more risky than the other one. But you have only money to insure, let's say, your production in one country. Well, then you want to buy insurance for the location where the Bernoulli's are produced, because if something goes bad, you would lose a lot there. So that is one application why that limits report might be useful. It tells you essentially in the production of which good are you more vulnerable. Okay, so at this point we should have a pretty good understanding of how everything works in linear programming and what the reports tell us once we pull them up. Okay, so let's stop here and then let's continue in the next video with some other special cases related to linear programming.